I fine-tuned an AI model on every YouTube transcript for my channel to make an AI model that sounds just like me. But instead of immediate success, something went really wrong. The model output was complete slop after hours of fine-tuning. What went wrong here? And how can you learn to fine-tune your own AI model without making my costly mistakes? Well, that's exactly what you're going to learn in this video, where I will walk you through the full data pipeline that turned my fine-tuned model from slop into something that truly sounds like me. When you look at other videos, most of them will only show you step 5, which is training or fine-tuning the model. But the first 4 steps are way more important. If your input data is poor, your fine-tuned model is not going to work at all. And there are many platforms out there that claim that you can fine-tune a model by just giving a couple of prompt examples. And this can work, but only if you have formatted your data properly. So in this video, you're going to learn about these first 4 steps, which will allow you to fine-tune a model properly. We're going to start with fetching your data. In my case, my YouTube transcripts are available on YouTube because every time I upload a video, Google automatically transcribes it. So I can use yt-dlp, which is a Python-based application, to pull all those transcripts from videos that I put in a playlist. So I select the videos that I want to use for the fine-tuning myself. Now, the automatic captions are okay, but they have some real problems that I'll show later. If you rely on automatically generated captions, you will see that there are going to be issues with spelling mistakes, weird formatting issues, or even the automatic transcription misinterpreting what you were trying to say. So you really want to clean this data, and I'll talk about how I clean it in just a little bit. Next, you need to rewrite your data as well, because when I create a YouTube video like this, I often explain something, but it's not in the same way as I would explain it to you if we were talking face to face. So if you're creating, let's say, an LLM chat out of your own model, then you want it to be rewritten in a way so that it makes more sense in a question and answer scenario. So instead of it being this whole long monologue, I have to rewrite my YouTube transcripts in a format that's much more like a question and answer format, where you ask me a question, I might acknowledge it and say, what a great question, and then give my answer, instead of it just being a really long monologue, which is the case for my videos. And then you have to augment your transcripts, or rather your training data as well. You have to create different styles so that different kinds of input questions can lead to good results. So in my case, it means that I want to maybe create a blog post in my tone of voice, but sometimes I want to create a YouTube script in my tone of voice. So I have to prepare my transcript in multiple styles so I can use my fine-tuned model for all of those use cases. So a lot of that is pretty intense to get right, but no need to worry. We're just going to be walking through all of these data pipeline steps together with some Python code examples so you actually know what you're doing. It's all about understanding the real concepts behind what you are doing. And once you know that, the rest will follow as AI agents become quite capable at generating the code for you. But it only does this if you know the concept. So that's why I'm here. Let's continue and actually walk through how I call all these different parts of the pipeline. Now, this code is just taken straight out of my repository, and all I do here is just run a couple of Python scripts, either a dry run, a fresh script if I want to create a new model from scratch, or just a regular run. Now, if you're doing this at a company, you don't just want to have a bunch of Python scripts that are stringed together. You could, for example, use Kubeflow or some other great tool like that to create a real pipeline. Maybe something like Airflow 2. There's a lot of options out there. But if you're starting out and you're creating a hobby project for yourself, you just need to have the Python code and string it together in the right order. That's a great start, and you can always abstract things away later. Your data is probably dirty to start with. In my case, my YouTube transcripts are full of issues. So first of all, Google creates these hard line break sentences which are really split mid-thought and not split based on, say, a full stop. And this is because the transcript is really just crudely broken off based on when I say certain things. It just breaks off every 3 seconds or so. If you were to fine-tune a model with this raw data, then this weird line skipping behavior would also carry over there. If you're fine-tuning a large language model, then unless you're working with the best models out there, if you're giving it bad input data, then the bad behaviors of the data will also carry over to the final fine-tuned model. So you really have to clean this up. Specifically, one of the other things you can do to clean this up is really get rid of some filler and repetition. What we're going to do is we are going to browse. First of all, this is not a completely accurate sentence, but then also a lot of this is not necessary to answer most user questions. So I need to rewrite my transcript because when you're asking me a question in an LM chat, I'm not literally showing you something like I would in a video. So I have to get rid of those finer details. And because Google uses automatic transcriptions, the speech to text is not perfect. Here it, for example, says browse to this get, which probably should have been browse to and get. And even some smaller things can really add up. For example, product names are often lowercase. Notion, which refers to the Notion app, should actually get a capital N, because that's how I would stylize it if I were to write it. Now, the main lesson here is that if you train with these run-on sentences with lowercase output, then you will get a garbage model as output. So how do we clean these transcripts properly? Well, let's have a look at that. First of all, let's look at a raw result and a clean result. And this is a real example from my fine-tuned data. For example, it starts here by saying the new Claude code update comes with one very important feature that you must know about. Claude is a pretty difficult word for speech to text to get right. Sometimes it, transcribes it as cloud. And the problem with this is quite obvious. It doesn't refer to Claude code at all here. So you want to clean it up and say something like, the new Claude code update comes with one very important feature that you must know about. And in addition to having this run-on sentence, you want it to eventually end with a full stop. So how do you clean this transcript? Well, you can use regular expressions in some cases, which will allow you to strip some systematic data, but very often you need to clean something with natural language. I cannot hard code a rule where Cloud code will be replaced by Claude code every single time, because maybe sometimes the speech to text actually doesn't have a space here. So this is where language models come in. Of course, we are fine-tuning a language model here, but you can also use a pre-existing language model to clean up your transcripts. In my case, I use a Mistral 14 billion parameter model that I run completely locally to clean up this transcript. And running Mistral on all of my thousands of transcript snippets took about 2 hours, but it saved 2 weeks of debugging training loss because I know that these are really high quality samples that I can now train on. We can start maybe by looking at a little bit of code that I've written to actually replace some of the problems I found with the YouTube generated transcripts. Now, these regular expressions are pretty difficult to read in full, but I think if I show you a couple and explain them, you'll get the point very quickly. So here it will get rid of some of the annotations that YouTube might add to transcripts. Here it gets rid of some of my stop words because I don't tend to say but sometimes it happens, and it will be very weird if that is represented in the text that the model outputs, right? So you want to get rid of that too. Now, this sort of works, but sometimes your stop words might not be captured in this kind of easy to extract way. That's where you want to use a language model to clean up your transcript. And so a system prompt can look like this. You can have a cleaning system prompt, which focuses on some common mistakes. And this really depends on your data, right? Obviously, if you don't have an AI engineering channel, you're not really going to say OpenAI that often. But in my case, I do, and it happens very often that it's split up in this kind of awkward way. So it's very good if you give a couple of common speech-to-text errors or whatever works for your data, just to provide the local AI model with a bit of context as to how to clean up the transcript. Next, you can also add a bit of a cleaning user prompt that is more focused on punctuation and capitalization, like adding periods, commas, and question marks where sentences naturally end. And the better local AI model you use for this, the better end result will be. So how does a large language model help with building your training data? With a language model, you can handle judgment calls. You can really fix up any sentences that don't have a clear stop, and you can even write 3 different questions for the same answer to just extend your training data. Now, there's 2 jobs that my language model does in the fine-tuning pipeline. The first one is clean. You give it a raw transcript chunk and out comes transcript with the exact same words, but then with punctuation and just the casing fixed, because regular expressions cannot tell where a sentence really ends. And the second job is to augment the transcripts. Here, I give it 1 clean paragraph, and the output is 3 different user questions with that paragraph as an answer. Now, why is it that I take my input paragraph like this one, you should never ship code you don't understand, and create 3 training examples out of it? Well, That's because when someone interacts with your AI model, you don't exactly know beforehand what question it will give. Maybe it's going to ask a direct question like, what's the right way to use AI coding tools? But maybe it's going to ask for an opinion. What's your take on shipping code you didn't write? Or maybe it's giving the model a specific task. In this case, it could be a writing task. Walk me through how to think about code you don't fully grasp, explicitly asking it to create a blog post. For all these different tasks, it is beneficial to have training examples because that's how you can fine tune a model to really perform well on one given task. In my case, I want it to perform well on these 3 different kinds of tasks so that my community members can ask the model a direct question, so that I can use the model for maybe scripting my videos or writing a blog post, and more generally for me to be able to extract opinions out of the model to see if it aligns with my own views, to see how well it's actually fine-tuned. So what does one of these examples actually look like in the JSON format that is passed onto the training pipeline? Well, you can see here that you will start with a system prompt. For example, you are Zen, an AI engineer. And then you can have a human input such as, what's the right way to use AI coding tools? And then your GPT answer could be something like, you should never ship code you don't understand. And you want to use the same answer for all of your human input values. This way, you're able to really train a given output on different tasks. Of course, feel free to change the paragraph output if you want, but for my use case, I kept the paragraph the exact same, and I just created many human examples to cover different use cases for my language model. And this really teaches the model to respond to the meaning of the question and not just always return the exact words that correspond to the training set. So how do we generate those instructions for the exact same paragraph output? Well, here you can, for example, see that I have a couple of instruction styles. I only copied over the direct question one. And this one basically says you are creating Q&A training pairs. Given a paragraph, write one focused question that this paragraph directly answers. Keep it to a single sentence. So this way, I really guide the local AI model to write a clear, direct question that actually works given the answer. And I don't have to ask someone to do this manually for me. I've completely automated the process using that local Mistral model. Now let's give you an exclusive look at the real repository so I can show you how I go from the raw transcripts to the cleaned and augmented transcripts. So let's open a random transcript here. This one is, I think, one of my local AI videos. Hi, my name is Zen, and you clicked on this video, blah, 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 blah. Well, you can see all of the issues that we described before. So now let's look at what a clean version of this transcript looks like. And the way that I'm going to do that is I'm probably just going to search for it here, F40, and then I can look at the cleaned data instead. You can indeed see here that this just looks much better. You don't have to read the entire transcript to already see that this is way more appropriate, but this is not the end. I still want to split this up and get it ready for fine tuning. So let's have a look at how I augment this transcript. So maybe I can find the snippet. This is a very popular application in some other parts of the cleaned data. So indeed, if you search for this is a very popular application, in my transcript pairs in the augmented data, you can actually find that transcript snippet back. And if you look at the instruction for this transcript pair, it says, what kind of hardware do I need to run LM Studio on my computer? And this is a question that Mistral generated based on this response paragraph. And it generated that because I talk about how, for example, if you're on a Mac, the app requires a modern M series chip to function properly. So that's why the language model created this question as a good training sample for this paragraph. But of course, this paragraph also appears 2 other times because remember, I'm creating training pairs for multiple scenarios. For example, it also appears here, and this is an opinion request. Walk me through how to get started with LM Studio based on whether someone has a Mac, Windows, or Linux setup. The exact same response is given here, but the instruction just makes more sense for the use case of asking the model's opinion. So this is really a great way to showcase that I'm reusing my transcripts, but they are just prepared in the right way for fine-tuning. And you're gonna have to do the same with your data. It's gonna be a tough process, but if you get there, you will see that you will end up with a much better end result. By the way, if you want to get hands-on with local AI today, check out my free projects in the link in the description below so you can actually get started instead of just watching theoretical videos. Now let's talk about a couple of techniques that you can use to optimize your fine-tuning process. And these are techniques that you don't hear many YouTube videos talk about because they're actually really useful and hidden from people who are just starting out. So pay attention because these techniques are going to help you out. One of the challenges I face with fine-tuning my model is how do I really get it to talk about my personality? Because most of my videos are really just about instructions. I talk about how you can use coding tools. I talk about how you can create fine-tuning pipelines. I talk about myself a little bit, but it only happens in some videos, and really it makes up a very small percentage of my total training data. But that is a real problem because I do want the model to be very aware of who I am as a person. For this, I use a technique called persona oversampling. With oversampling, you're listing the exact same training rows multiple times in your data sets. And this way, you benefit from the model learning by the frequency of how often you repeat something. The more often it sees a row during training, the more it treats that pattern as the rule. So in this case, I might have some explanation about why I sometimes like to work alone, and I just literally duplicate that in my training set. Why do we do that? Well, because my spoken words about who I am as a person doesn't appear that often in the training set. You can see that, for example, out of 5,000 transcript segments, only 50 talk about me as a person. But that is such a small amount of the training set that if you were to ask the model about who I am, it probably wouldn't be able to respond properly. So I want to oversample, I want to duplicate that information about myself 10x. So for me, this is kind of the cap. I set it to a 10x value because if I go too far here, then the model will just parrot persona answers on completely unrelated prompts. So it can take a little bit of time to get the values right, and it of course depends so much on what you're trying to achieve. But it really is a good technique that you can use to over-represent certain training data that you really want the model to be able to recall later on. Now, another very important thing about my training data is that I split up my transcripts. I have videos that are 47 minutes long, and if you convert the words into tokens, which is what you want to use for training, well, it's a lot of tokens. It's thousands of tokens. But that's not really good training data for when you ask my AI a simple question. Maybe you just want to ask it about its opinion about coding agents. Well, I like to respond pretty direct and brief, so it would be super weird if it then responds with a 300-word essay. So in my case, I want to cut up my transcripts so that the model actually responds like how I would, but also shorter examples are great because you can train much faster. And the reason for that is because the attention mechanism that's used during fine-tuning means that when you have a token in a training example, it will compare itself to every other token in that training example. That might sound a bit confusing, but it just means that you will do n times n comparisons, which is a lot. So one quick example here is that in my case, I used to have around 1,200 tokens for an average input example, and I slimmed that down to just 140 tokens. So it became much faster to fine tune my model, which is great because it's cool if your fine tuning takes 60 hours, but if you make one single mistake in your fine tuning process, then you have to start training those 60 hours all over again. Whereas in my case, because I applied this optimization, my fine tuning only takes 1.5 hours on some models. And that's great because if I make a mistake, I can probably just retrain again. It's a lot easier to do it if it only takes 1.5 hours compared to 60, right? So this was a great technique that I applied myself. Now, once you've mastered data engineering, the next step is to just split up your data in training and validation, but we will talk more about how to actually get the fine-tuning training process started in a later part. So check out my free local AI projects in the link in the description below, and make sure to subscribe because I'll be following this up with many more videos to teach you real AI fine-tuning. So I'll see you next time.